field at a point which is very close to the surface of the conductor is sigma by epsilon 0 n hat. Direction we have already talked about direction earlier. Now let's talk about the magnitude also. See, if there is some randomly shaped conductor, right? But if you look at a very small portion of it, then it would appear flat. Yes or no? Yes. Everyone realizes that however curved it might be, but if you watch a small portion, it looks flat, just like Earth. Okay. So suppose here we take a cylindrical Gaussian surface like this. Let's say we take a cylindrical Gaussian surface, means we are going to use the Gauss law for this. Now suppose the surface charge density is sigma over here. Surface charge density is sigma. Right? Obviously, assuming this is having some charge. Is it fine? Yes. Okay. So let's say this has a surface charge density. Now, electric field due to this over here is 0 on this side. Came inside the body of the conductor, the electric field is 0. Yes or no? Yes. Sure. Yes. Okay. Now if we take the curved surface, then the electric field we know is normal to the surface. They would say a normal vector arm there. Yes. Like electric field near the conductor is normal to the surface. But the area vector of the curved surface, area vector of the curved surface will be like this. Clear or not? So angle between electric field and the area vector will always be 90. Is that okay? So the flux for the curved surface is 0. Flux for the left side flat surface is 0. Yes? No? Yes. Sure. Why is the flux 0 for left side flat surface? There is no electric field over there. Clear or not? Baki should you have it. Flux for the right side flat surface. Clear? Yes. Flux for the right side flat surface. Now here, electric field is in this direction. Area vector will also be in the same direction. Yes or no? Yes. Okay, so the flux will be phi, which will be equal to E into A into cos 0. Is that okay? Yes. And this is again infinitesimal. So everywhere here we can assume that the electric field is uniform. They are very close to each other, right? There is a very small infinitesimal Gaussian surface. So this is flux, but we know that flux is equal to, for a closed surface, flux is equal to sigma q enclosed upon epsilon 0. Now here this Gaussian surface only encloses charge over here. Yes or no? How that? Yes. How to imagine that? Take a piece of paper, put a cylinder through it. Okay, so where would it cut it? In a circle. Yes? No? Yes. Cut it in a circle and it enclosed charge and enclosed. The charge on that circle is the enclosed charge. Got it? Yes. Right? Again, charge is only over here. So that would mean the total enclosed charge is sigma into A. Why sigma into A? Yes. Charge on the sheet in shape of circle. Sigma. Surface charge density multiplied by area. Yes. Here Q equal to sigma into A. So we get Q equal to sigma into A divided by epsilon 0. So what's cancelled? A cancels, cos 0 is 1. So we get E is equal to sigma by epsilon 0. Okay, E is equal to sigma by epsilon 0 in magnitude, and we already know the direction, isn't it? That it will be normal to the surface. Did you understand? Yes. But be careful. Where is this? This is very close to the conductor. Okay, very close to the conductor. But see, you know that. Suppose I tell you that this has some charge Q, and if I tell you that there is a point P at some distance, and then you say electric field will be sigma by epsilon 0. Wrong. Where to use it? Here at the surface. Okay, don't use it at some distance. Got it? Right? Done. I'm erasing the heading. It was a very easy proof, wasn't it? Yeah, would you like to know? We have had a similar proof for a sheet. Do you remember?
Yes.
The difference was that in sheet the electric field is on both sides. Here inside the conductor the electric field is not there. Do you remember that? It's one of the previous properties, right? Okay. So that's what we have for the properties of the conductors. We'll not have anything more, I assure you. Okay. Now let's talk about a word that you are already aware of. Ground or earthing. We have studied it in chapter 1, correct? Okay. We connect something with earth, so it takes up the extra charges. That's what is called earthing. So suppose this is some object, some shell, something that is ground. Now here we are going to just understand one. Is that whenever you take some object and connect it with the ground, often we are taking the ground as the reference. It means this point will be considered as the reference forward for potential. Do you remember potential as a reference? Yes or no?
Yes.
Okay, everyone remember that? Potential as a reference. Its value is not important unless you specify what is the reference. Right? So, it's a simple idea that whatever you connect with the ground, that thing will have V is equal to 0. Completely clear? Fine. It's just like, do you remember when we used to take U equal to MTH? We often used to take reference at the ground. So this idea has a similar, logic going on, right? When you connect something to the earth, we say that it is at 0 potential. Remember, it's a reference. Okay. Fine. We'll have to use this in some questions, right? Often you'll see diagrams, and in the diagram, it will be drawn like. Then you understand that this point has 0. Okay. Sometimes it will be given in the word form that this shell is earth, like that. Okay. So you be careful about it. Now, potential due to various shapes. So first of all, potential due to a thin, uniformly charged spherical shape. Okay, potential due to a thin, uniformly charged spherical shape. We have already found electric field due to shell. Do you remember? I hope you do. Okay, there's not much more I can do about it, except giving a booster dose of chapter 1's vaccine. Yes or no? તેને તમારામાં antibodies કહેવાય ગયા. Okay, so antibodies go there. Okay, well then. So suppose there is a uniformly charged sphere. Let's say it has a positive charge Q, uniformly distributed on its surface. Here is center. Let's say radius is R. And here is one point P. First of all, we are targeting outside region. Okay, suppose this point is outside. Okay, now at the outside part, what's the electric field due to a shell? K Q by R square in magnitude, and direction will be R hat. Same as point charge, yes or no?
Yes.
Yes or no?
Yes.
So if the formula of electric field is same as point charge, I hope you realize that it is reasonable to expect that the formula of potential will also be same as point charge, obviously. Integration then थोड़ी कवर कर सके आप point charge की formula देखा shell नहीं make sense or not? Integration तो इन्हों काम करेगा. So ultimately, it is not a big surprise that we will get this. समझ गया ने? Proof. करूँ मैं proof. करूँ अच्छे भाई. एक वस्तु के लिए और कर दो. So Vp is equal to kq by small r. Again, you can also do this just by assuming that all the charge of the shell is concentrated at the center because this point is outside. When your point charge okay, the distance between these two will be smaller. Is that okay? Terms are clear? Clear or not clear?
Yes.
So thanks. So this is the potential outside the uniformly charged. Now time for inside. Okay. diagram drawn already. ઉતાવળ રાખજો મુનાની જો હોય. So let's talk about inside. So suppose here is a point and this is polar and which is less than the radius. So this point is now inside the shell. Fine. We want to find out what the potential here. So suppose that there is a point S on the surface anywhere. Suppose that there is a point on the surface. Anyway. Then, do you remember what the electric field inside the shell? Very good. Inside the uniformly charged shell, the electric field is 0. So now if I want to find out Vp, I am going to start like this. I hope you are not at all surprised by this formula. Okay or not okay?
Yes.
Sure? Oh, right. Wait. So, between P and S at every point, how much is electric field? 0. Sure. So that integration is also 0. Got it? Absolutely clear. If integration is 0, it means Vp is equal to Vs. Is it fine? So we can write potential inside the uniformly charged shell is same as at the surface. Got it? But how much is it at the surface? For surface also you can assume that all the charge is concentrated at the center because surface and outside was equal. Is that okay? Earth surface is outside the earth, not inside the earth. Okay? So this point S you can consider it to be like outside. So I should put what? Capital R. Clear or not clear?
Yes.
Why capital R? Because distance of that point S from the center is not polar but capital R. Got it? Sure or not sure? So जो potential ની other formula meaning. So if someone says what's the formula of potential? So K cube by small r नहीं कही जानो आप बंद करें. पहला पूछवानो. Due to what and where? We have it due to point charge. We have it due to dipole. Do you remember? And now we have it due to a thin spherical shell. But we have inside and outside. Okay. Now, interesting feature of this formula. Does it depend on this distance r? No, it is same everywhere inside. Got it? Clear? Right. Do you also realize why it should be like this? Do you remember electric field magnitude kind of indicates how quickly potential is changing? Do you remember that or not?
Yes.
Yes or no? But if electric field is 0, that means potential is not changing. So there is no surprise that we are getting. Say here. Understood? Relative ke nahi? Physics, maths to barabar. I am saying why is potential not changing anywhere here? Because the electric field is 0. If electric field is 0, potential will not change at any of those points. It will be same. Clear? अच्छा, आनो ग्राफ ड्रॉ करता outside, inside. Here. First horizontal line and then like this. Is it clear?
Yes.
Sure. This is R equal to R. Here is K cube by capital R. This is the maximum potential. But yeah, inversely proportional to R on the outside. Got it? Fine. अब उदाहरण to gravitation. Ditto. Okay. Now let's go to next shape. Potential due to non-conducting uniformly charged sphere. Potential due to non-conducting uniformly charged sphere. My path a big first one outside. So here is that thing, okay, which has a charge. Let's say radius is r. This is n. This is point p. This is at this is smaller. Okay. So where is the charge here? Is it only on the surface? Is the charge on the surface or is the charge everywhere? Everywhere. Here the non-conducting uniformly charged sphere. The shell thing. That's the difference. Shell only has a surface. Okay, especially if it is thin. So here they scattered everywhere. Let's say the total charge is Q. Understood? But this point P is outside. So electric field formula will just be kq by r square. Is it fine? If electric field formula is kq by r square, just as it was one point and the potential outside will again be kq by small. Understood? No derivation provided. Okay, understood. Right? Easy to do that? Okay, part B now. Okay, so now let's consider a case where this point is not outside but inside. How is derivation gravitation માં કર્યું છે? Okay, let's say the point P is here. And again, suppose there is a point S. First of all, do you remember electric field due to? Do you remember electric field due to a non-conducting uniformly charged sphere inside the sphere? Do you remember that? Who remembers it? Who remembers it? Raise your hand. Come on. Out there. No out there. So koi વાંધો નહીં. I would say, give it a try. Yes, Divya. Hurry up. Very good. K Q small r upon capital R Q. Is that okay or not okay? Right. We are going to use this. Now this is in scalar. In vector form, this would be like this because it would always be the radial direction due to the symmetry. Sphere then the badi baju radius same like that. So there is radial symmetry. Because of that, it will be in that direction. Now time to find potential difference between P and S. They will okay. So only one difference. Here the electric field is not zero, so it's not that is X okay. So the Vp minus Vx is equal to negative integration S to P E vector dot dr vector. Clear or not? Okay. Now Vp minus what is Vs? We'll put it later. We'll put it here. Electric field formula. Okay, if you do dot product and everything, finally this minus sign here. R hat dr vector. What is dr vector? Do you remember? Dr vector is dr r hat. Yes or no?
Yes.
Check with the movie though. So then do you realize that where S is, we'll have to write capital R. Clear or not?
Yes.
Why? Because S is at how much distance from center? A capital R. But P is, there we will have to write smaller. Understood?
Yes.
Sure? Okay. E vector dot this. Here they just say K Q R by capital R cube R hat dot R hat is 1 and only dr will remain. Fine. Okay. Therefore, Vp minus Vx is equal to constant outside. K is constant, capital Q constant, capital R constant. Clear? Integration of R square by 2. Okay, so 2 is here. 2 is here. Integration of R is R square by 2. So 2 is here. Now we have R squared and now we have to put limits. Lower limit is capital R, upper limit is smaller. Okay. Now Vp minus. This is the best time to put Vs value. Vs, this is on the surface, yes or no? So on the surface, the potential will be kq by capital R. Clear? Sure? Because this point can be considered to be outside. And there the distance will be capital R. So kq by capital R is equal to minus kq by 2r cube. R squared minus R squared. Got that? Okay. Now those who are great at mathematics will cancel k with q and 1r. Okay. બીજા બધા અહીંયા ધ્યાન રાખો. Okay, those who are not so great at mathematics. So we will put kq by r on that side. Clear? Okay or not okay? Sure. No, cut no karna. So this is what we get. Right? Now we take LCM, but we'll also take K and Q common. I'll not take R common. Okay, another part undo out there. So LCM. So this will give us R squared. Got it? Or not clear? Acha 2 R squared. We'll take 2 also as LCM. Did you understand what I have written so far?
Yes.
Sure. minus અહીંયા LCM લઈ લીધું એટલે 2r square આવ્યું minus kq is what r square minus minus plus r square got that clear or not sure join the બરાબર kq common 1 આવી ગયું here we have 2r square missing so 2r square minus like that so this is equal to kq by 2r cube capital R over here what do we get 3r square minus small r square so this is the formula of potential inside the solid sphere not conducting हो जाए conducting હોય તો શું થાય એ હમણાં આપણે ડિસ્કસ કરી લેવડાવું ઓકે આવું ગ્રેવિટેશન માં આવતું -gm/2r cube 3r square minus r समझ तो पड़े જ ને એકલું મેથ્સ જ આવે છે બેઝિકલી રાઈટ વે જસ્ટ ડુઇંગ ઇન્ટિગ્રેશન એન્ડ એલસીએમ એન્ડ ધીસ એન્ડ ધેટ ફિઝિક્સ કેટલું હોય બસ આ આવડે ને આવ ગયા બે છે એના પછી તો કઈ કરવાનું નથી ડુ યુ સી ધેટ યસ ઓર નો એના પછી એક પણ ફિઝિક્સ ની ફોર્મ્યુલા નથી આવતી ઓકે What if it's a conducting sphere? Okay, it doesn't deserve a separate derivation. And તમારે સાથે discuss કરવું. What if it's a conducting sphere? All the charge will come on outer surface. Everyone remembers that charge cannot be on the inside; it will be on the outer surface. Clear or not? Yes. Then it will behave just like a shell. Got it? Yes. બધો ચાર્જ બહાર જ હોય ને અંદર તો છે જ નહીં એટલે પહેલા ડેરિવેશન કર્યું like a shell. Okay. Look it up. Behaves just like a shell. Fine. So there is no need to derive it again. 40 minutes. अच्छा आनो ग्राफ तो नहीं करो. आवड़े कि नहीं? Outside part, not for this, huh? Again for not conducting sphere, and now it won't behave like this. What would be the graph like? If you put small r equal to 0. If you put small r equal to 0, means at center, yes or no? Yes. Okay, how much would it be? 3kq by 2r. Got it? Yes. In a easy 3kq by 2r. But by the time you reach the surface, at the surface, the potential will only be kq by capital R. Yes or no? Okay or not okay? Outside the bada ne out say proportional to 1 by r like this. Got it? But અહીંયા શું? How નહીં આવે? From here to here it will decrease. But because this is power 1 and this is power 2, so it's a quadratic equation. Yes or no? Yes. Everyone sees that this is a quadratic equation. Okay, with one variable has one power and other one has in a parabolic shape. Is it fine? So from here to here, we have to join. Arm nahi hai. Smooth so basically at this point there should be no corner. Okay, there should be no corner. And let's see, I'm join to it. Slope must बनाई दो भाई लोग से पार. Clear? Okay. So this is at the center. R equal to 0 at the center, right? This part is inside and that part is out. Next one, due to a ring, potential due to a uniform ring on its axis. Potential due to a ring on its axis. Here's point P. Let's say this ring has total charge Q. Its radius is suppose capital R and this distance is small r from the center. Okay? Okay or not okay? Everything clear so far? I am not saying the ring is uniform. फर्क मत पड़ता. Uniform होगा कि नहीं? Okay? No problem. See. If this is a point P and I want to find out what's the potential here, then obviously this is not a simple shape. we'll have to do integration. Clear or not? We will have to do integration. So we take a small part. Suppose here this charge is dq. What's the distance of this charge from this point? The hypotenuse, that is under root r squared plus r squared. Now even if there was any other point over here or over here, do you realize all the points are at same distance?
Yes.
From that point?
Yes.
All the charges here, anywhere, they are at same distance.
Yes.
Raise your hand if you see that. Okay. Here the time. Compass. તમે યુઝ કર્યો તે કોક દિવસ કે ન કર્યો આજ સુધી આવી રીતે તમે કરો. You realize that when you do that, all the points will be at same distance from here. સમજ પડે આવી રીતે તમે કરતા હો. That's the circle that you are drawing. આમ draw થાય. Do you realize it's just like this? The distance of all those from this center will always be same. Yes or no? આમ કરે ખાલી angle આમ change કરો. Yes or no? The direction just turns. Right? The length remains the same. So that's why, or that's how you can consider that distance of P point from all these points is just the same. How much? Okay. Now potential scalar or vector? Scalar. The direction क्या होती है? So due to small dq charges, the potential is dV equal to k dq by under root r square plus r square. Clear or not? Sure. Yes or no?
Yes.
Small r no है because distance of p from the charge. How much is it? Got it? Clear or not? Now, if you add all the potential due to this direction to the question of the this, do you realize all the potentials are going to be same?
Yes.
Yes or no? So if you do addition or integration, everything is constant. So finally, basically I am saying that the whole charge Q, whether it's here, anywhere, all the charge is at how much distance from point P? At same distance. Clear or not clear? Clear? Then. So one thing, in a ring, can you assume that all the charge is concentrated at the center of the ring? Yes or no? Yes or no? Oh, we tell them. No, is that clear or not? Because if you assume it's concentrated at center of ring, then potential will be k cube by small r, which is wrong. It's not k cube by small r. It is k cube by under root r square plus r. Got it? Clear or not? So this is the formula of what? Potential due to a ring on its axis. Bar side में आवश्यक कोई दिया तुम्हारे नहीं है. Okay. Why have we not written uniform, non-uniform? It doesn't matter because, like I said, wherever the charge is, the distance is always the same. Electric field ma uniform जरूरी है. When we wrote the electric field formula, I think is small r upon under root, I mean r square plus r square is 3/2. You got it? Electric field uniform for a ring.
Yes.
Okay. So here it's not necessary. Uniform, non-uniform बदल कर. Got it? Okay. आनो ग्राफ तो बनाता आवड़े कि ना आवड़े? Not that tough. Okay. Where will it be maximum if you put small r equal to 0? Yes or no?
Yes.
If you put small r equal to 0, it will be maximum. K cube by capital R, where small r is equal to 0. Okay? Then we start to say, and then it will just decrease. Is it fine? It will keep on decreasing. Got it? Okay. Shall I erase it now? Sure. एक सेकंड में मैंने कंफर्म कर लिया ग्राफ बराबर ड्रॉ થઈ ગયો ને I did it very casually. Suppose व्यवस्थित करू है तो KQR R square plus R square equals 3/2 આવું જ આવતું હતું ને so initially the slope of the graph is 0 ના તો આમ નહીં આવે just one thing and gradually the slope will start to decrease the negative initially it will be 0 okay it will be like this. There will be a curvature of this kind. First, it will come down like this and then it will turn and go there. Our body can simple. Let me. This is electric field. Do you remember electric field is actually obtained by doing differentiation of potential, roughly speaking. Yes or no? In a slope sign. Our medical electric field is like the slope of potential. Yes or no?
Yes.
The starting means at R equal to 0. How much is the electric field for a uniform ring? At least R will be 0, so E will also be 0. Clear? So at the start the slope should be 0. Arm chalu to hoga. Arm ne. Make sense? What is it? The graph should start with a horizontal tangent, not an inclined tangent. Clear? But then eventually what happens is as you put bigger and bigger values of smaller are negligible now. Make sense? If you put bigger and bigger values of smaller, capital R will become negligible. એટલે પછી આ કેલા જેવું થઈ જાય like k cube by r means like a point charge એટલે આટલો જ ગ્રાફ હતો ને જો then it should look like point charge. But when r is small, that time it should not look like a point charge. Is that okay? એટલે કરેક્શન કરી લેજો પહેલા જે ડ્રો કર્યું ઉડાડ દેજો ઓકે let's not be so careful. Initially it should start off a little bit horizontal and then slide down like this. Well, let's go to the next topic. Potential difference due to a long, straight, uniform wire or uniformly charged wire. Electric field वालों याद है ना? कि नहीं? फॉर्मूला भूल गया जो कि याद है electric field of a long, straight, uniform wire. E is equal to lambda by नहीं चाले lambda by 2 pi epsilon 0 r. Yes or no? आंसर आप एक पढ़ते हैं कंटिन्यू करना सीख जाओ एक मिनट okay so here is long straight wire it's uniformly charged so suppose it has charge everywhere like this linear charge density is lambda okay હવે આ કોઈ ટોપિક ટેક્સ્ટબુકમાં એકવાર નથી એટલે કઈ લખવાનું ઝંઝટમાં નથી ડેરિવેશન માં નાખી here is the point P right that's a point P now E આપો અને P okay let's say E is at a distance r1 and P is at a perpendicular distance r2 okay now we are going to find out what is VB minus V we are going to find out what is VB minus VB अच्छा electric field you will suppose is positive charge then electric field will be towards the right side that is away from the sun अच्छा तो એના માટે formula did you understand yes or no કે r hat means going radially away આની ઉપરથી જવો તો કેવું દેખાય યાદ છે ને આમ બધી બાજુ ઇલેક્ટ્રિક ફીલ્ડ આમ જતો હોય coming out from the wire આ wire do you remember that yes sure I hope you do okay so we get this dot dr vector માટે શું લખવાનું dr r hat so r hat dot r hat will be what we have to do integration from a to b clear why a to b is clear yes or no sure formula છે ને oh fine therefore શું આવે constants out what is constant? Lambda 2 by epsilon 0. બાકી શું લીધું? Integration of dr by r. શું થાય? Integration of 1 by x dx. What is it equal to? કોઈ વસ્તુનું integration constant ના હોય. અરે ભૂલી ગયા. ln 1 by integration of 1 by x dx is ln x. ચલો કઈ વાંધો નહીં. So ln r. Okay, and a means distance r1, b means distance r2. બધું મૂકી દો એટલે આવું આવશે. db minus va equal to lambda by 2 pi epsilon 0 ln r2 minus ln r1, log property. So this will become r2 upon r1. Got it? Yes or no? Sure? So it's pretty then. ln r2 minus ln r1, log property. Log a minus log is log a by b. Fine. Okay. તમને આવું યાદ રાખવું ટફ પડતું હોય તો r2 ની જગ્યાએ શું લખી શકાય? rb અને r1 ની જગ્યાએ ra. That also will do. Is it fine? Clear or not? Sure. One by r no integration ln r થયો and then we have put limits. Fine. હવે યાદ રાખજો. What this? This is the formula of potential difference for what? A uniformly charged long straight wire. આમ જો તો અઘરું મેથ્સ સ્ટુડન્ટ માટે તો કંઈ જ નથી આમાં. અને આપણે વાળી ફોર્મ્યુલા ઇન્ટિગ્રેશન કરો એ એક જ સ્ટેપમાં આવી ગયું. આ અહીંયા તો આવી ગયું તો પછી તો કંઈ નહીં સબટ્રેક્ટ કરતા તો ક્લિયર? માઈનસ n ઉઠાઈ ગયો એવું થયું. Just a second. Yeah, you are right. I didn't realize that there is a minus. So, minus sign is missing. Clear? Oh, make sure you write the minus sign though. ઊંધું કરીને લખી શકાય. એ તો ખબર ને log ની property. Minus of log is log of 1 upon. Here is it high. If you want, you can write it like that. Also, add one more step. Minus કર્યું ને બધાય. Okay. So that is what we have for the potential difference between long straight uniformly charged. Sheet no nahi karo. Okay. Electric field of sheet is uniform. Yes or no? Everyone remember that? Okay, તો એમાં કઈ ઇન્ટિગ્રેશન માં છે ને just put electric field outside. Okay, એક general case કરી નાખીએ અને એ બધામાં ચાલે. If electric field is uniform, if electric field is uniform, use it only and only for this. Do not use it for anything else. Okay, then delta V will be negative integration of E vector dot dr vector, then that would be equal to, suppose from A to B, then that would be equal to, if electric field is uniform, take it outside. Okay, is that okay or not okay? And suppose we go in a straight line, then cos theta will also be constant and the NA bar this side. Then what is remaining is actually integration of dr. Integration of dr is r. Yes or no?
Yes.
Not very good. If you are moving in a straight line, see, nobody can tell you how to move or how to take a charge from one point to another point. Is that okay? You can actually take it on any way because it's conservative. The path does not matter. Everyone remember that?
Yes.
Put E outside, angle outside. What's remaining there? Integration of dr, rb minus r. So in the vector form, delta r. So there are two ways to write it. One is this, or the other one is this. Did you understand? I'm not sure how to make it work. હા એક વસ્તુ ઘણા લોકો પછી આનાથી બહુ આગળ પહોંચી જાય છે અને આવું કરવા માંડે છે બધી જગ્યાએ. જે તમને આવું કહે ને કે આવી રીતે કરવાનું. This is how you find potential or potential difference from electric field. Okay, stay away from that person. Got it? Both તમને clear થઈ ગયું. V equal to ED is one of the most misused formula. આ formula સાચી જ છે પણ એ યુઝ એક જગ્યાએ થાય ને 50 જગ્યાએ યુઝ નહીં કરવાની એવું છે. Is that clear? Use it only in a very specific condition. તો એ condition એક જ છે પણ બીજી કેટલી જગ્યાએ આ ફોર્મ્યુલાનો યુઝ ન કરાય એવું છે. પણ એ તો તમને ખબર જ છે એકવાર તમને કોઈ ઈઝી ફોર્મ્યુલા દેખાય એટલે તમને બધે is use કરવાનું મન થાય કે નહીં? Yes or no? So be careful. Okay, this is true but only in one case. It's not even true here, to be very frank. It is not even true if electric field is uniform. Right? Over specific formula. So I suggest that you don't even try to remember anything like that. Okay. Well, I believe with all this we have covered the potential part of the chapter completely. How do I think? Electric potential and potential gradient. Potential gradient means dV by dr. Electric field assume the relation of potential with electric field. Okay, right, let's start. A charge 3 coulomb experiences a force of 300 Newton. First question, 11th question from the assignment. There is a charge Q here. How much is the charge? 3 Q. And how much force does it experience? 300 Newton. Okay, force acting on that charge is 300 Newton. When this is placed in a uniform electric field in some direction, is that okay or not okay? All right. Then, what's the question? The potential difference between 2 points which are separated by a distance 10 centimeter along the field line. Here the draw करें ये point होगा ये point की the way should I draw it? Along the field line. So on any one field line I can draw 2 points, one A and one B. And now we have to find what is the potential difference between them. Is that clear or not clear? Sure. Absolutely. આવ્યું ને પહેલા ક્વેશ્ચનમાં એનો આવ્યું is the field uniform here? Yes or no? Yes. So can we use that? Yes. Let me tell you હું તમને જે લખાવું એ બરાબર લખાયું હોય. That is in all cases in the world for uniform field you can do this. Got it? Don't remember anything like V equal to ED or any other formula. બરાબર એ પછી ક્યારે મોટું પડી જશે તમને નહીં સમજ. Okay, so let's use that here. Which point is final? Which point is initial? Look at this. Final minus initial. Which point is final? Yes.
B.
A is final. B is initial. Is that okay? अच्छा यूनिफॉर्म से એટલે આ રીતે કરना है. सपोज तुमने આ યાદ ન રહે તો वन મેં ક્યાં ઉભરું છે જરા इंटीग्रेशन में e તો બહાર કાઢવાનો એટલે તો આવડે જ ને. if electric field is constant put it outside. Okay, so we get minus. You are going from A to B. Is that clear? No, sorry. You are going from B to A. Displacement is from B to A. Did you understand? Yes. No cover. Displacement what is it? Final position minus initial. So which is final? A or B? A is final. B is initial. So આપણે ક્યાંથી ક્યાં જવાનું? B to A. Got it? Sure? Absolutely clear? Acha, so minus. What is the? We will use this way. Okay, this one. That's right. Mine. Electric field magnitude. Can you find electric field magnitude from given data? How much will it be? 100. Yes or no?
Yes.
Can they be 100? Okay, first chapter formula. Displacement magnitude. Displacement magnitude. How much is the displacement magnitude from B to A? Read the question. 0.1. Sure, 0.1 or not sure?
Yes.
Okay. Now the angle between them. ક્યાંથી ક્યાં જવાનું? We want to go from B to A. આપણે એ રીતે લખ્યું છે એટલે ઊંધું કરો તો આન્સર સેમ જ આવે, સાચું કરો. And electric field line is from A to B. Yes or no? So what's the angle between displacement and electric field? 180 or 0? 180. Sure. What 180 is? So final answer is. What's the final answer? Understood?
Yes.
આવડી ને? Okay, integration થી થાય. Main thing is dot product here. To do the dot product correctly is the main thing. બાકી તો કઈ છે? Fine. Okay. Alright. We will continue the next. Right?